So the next concept is again relatively easy. That is very similar to what we learned in the nested if. Any question? Okay. So what we are going to now learn is what we call it nested if. Okay. Nested if is super easy. There is not much involved. It is just a concept. There is no new syntax. Nested loops. Right. So nested loop is very similar to nested if. Remember how we said if some condition 1 is true, then inside this we say if the second variable condition 2, then this, for example, take real life example, say if rainy equal to false, that means it's not raining, and if temperature is greater than 60°F, I'm taking Fahrenheit, then you want to play or do something. Otherwise, you want to do something else. And else, it can be another thing. If it is not raining, but temperature is this, then you have more if else. So this whole block is inside an if block. This is what we call it nested if. And we learned this. Similarly, I'm going to do that nested loop. In the nested loop, we are saying one loop inside another loop. Why do we do that? It depends. There could be list and there you have to process two separate lists. Suppose you have a list of names. So names equal to, let's say, Bhagyashree. We have Namrata, right? So Bhagyashree, Namrata, we have Sakshi. We have Spnali. We have Anuja. Okay. And we have Vaishnavi. Did I miss anyone? I may have missed somebody. Okay. Anyway, Apeksha. So I'm going to say, since I already used age, I'll say AP. Apeksha. These are list of my students. And say I have the numbers, their roll numbers, or I have their, marks. Let's say marks. Marks equal to, let's say all of them are 91, 95, 98, right? 100, 96, 95, and another number 97. I want to, now I have got two lists. So in one list, I need to iterate this list from here to here like this. And then I also want to iterate this list from here to here. Correct? So the way I will do it is I can use two lists, but this is not a right example, honestly, because at any point of time, every student has only one marks. Bhagsri has 99, Namrata has 95, and so on. So this is not a good example of a two lists where you will use iteration. Why? Because whatever is the index here, suppose index 0, same index 0 I can identify. So suppose if I start iterating this and I say for n in names, right? I want to print the name, print n. But now I also want to print the marks. So should I use another loop inside here? Should I say, similar to like what I was talking about, loop inside a loop? Loop inside a loop, first thing is, I forgot to tell you actually. You will say for x in some list. And then inside, you will say by one tab, you will say for y in, mostly you will say some another list 2. And then you will process. So what is going to happen is you are first processing top loop. Top loop comes for x in list. Let's say first name is Bhagyashree. Then you will say for y in list 2, which is marks. That means you're processing all of this. And then you are saying for y in list. That means you're saying now each entry 99, 95, 98, right? For in the second loop. But problem is Bhagsri only has 99, not 95, 98 and all that parts. I don't need to iterate second list inside this first list. It doesn't make sense because I can simply say whatever is my counter, I can say, suppose I keep a counter called int x equal to 0. I can retrieve from this list. I can simply say marks and I can pass that number x. This will give me the particular number from this list because this is an index and I'm keeping an index here for I equal to x equal to, and then I'll say x equal to x plus 1. So next time it will be second number, third number, fourth number, and n is coming from on the top here. So all basically I'm saying is the name, when I iterate this list names, I am getting B. I'm not getting the index of B. So I have to create my own index and use that index to retrieve corresponding number from the second list, right? So that is why this is not a good loop inside a loop situation. But I wanted to tell you the reason I started with example to show you just because you have two lists doesn't mean you start loop inside loop. Loop inside loop concept applies when for one parent entry in the top loop list has multiple entries in the bottom loop. Okay, let's take that as an example. Suppose you are writing a list, a table, and that's a perfect example of a two-dimensional data where you will have this is first row, second row, third row, and fourth, fifth row. And then within that, you have 2, 3, and 4. So suppose this is your name. This is roll number. This is marks. This is gender, boys or girls, and this one is like say attendance. Right now, for Namrata, she has her data in one row. For Apeksha, she has data in second row. For Vaishnavi, she has data in third row, and so on. So in this case, every student has more data, more columns for every row. So take an example of this row. This is student, second student, third student, fourth student, and fifth student. And each student has data points again inside. You can think of this as one list where you have name, roll number, this list. Then you have second list. You have third list. So you can see it's an array of array. It's a list of list. So this whole thing is a list. Inside there, what happened? Inside there are 3 lists. This is a good classic example of loop inside a loop because first loop will iterate a student, and in each student you want to iterate each cell like this, right? This is a good example of loop inside a loop because you are dealing with list of list, not just two lists. You're doing list inside a list. If that is the case, then you use loop inside nested loops. Okay, makes sense? So how will you do? You will keep this list and say for X in, suppose say top list. And then X itself is a list, right? Because this is a list. Then we'll say for Y in X. Now this Y is each cell. So whatever you want to do it, print Y. Right? So you are dealing with a top list which has 3 rows, and each row has 6 or 7 columns. So this is for rows, and this is for columns, and this is for call row, and this is each cell. This will give you each cell because now you're dealing with individual cell, this individual cell. Okay. So this is how, again, this loop is deal with each in X. Once this loop finishes, then it goes to our outer loop, and deals with next entry, which is next row. Then we'll go to next row, it will go here, next row. Make sense? I don't know if your screen is refreshing or not, but because I don't see my screen being refreshed. Okay, so this is how you deal with second list. Okay, and there is nothing much in this one. It's relatively simple. You can, again, in the top list, you can use loop here. You can use a range here. If it is a number, you can use a range here also if it is a number. So suppose I want to create a table. Let's take one example. Suppose I want to create a table of numbers. I want to take a number n. This will be n square. This will be n cube, and this will be n to the power 4. Suppose it's 1, 1, 1, 1. 2, this will be 4. This will be 8. This will be 16. For 3, this will be 9. 9 into 9 is 81. 81 into 8 is 729, I guess. This is 4. This is 16. This is 64. 260, 256, I guess. Suppose I want to print. So I have a list here. And each list has these 4 entries. So you can see, anytime you're dealing with tabular data, where you have rows and columns, it's a classic and perfect implementation of loop inside a loop. And you can, if it is 3-dimensional data, then you can do 3 loops. You can say for loop. Within that, you can say another for loop. Within that, you can say another for loop. And you can keep going as dimension increases. But usually anything after 3 loops, 3 fors, gets very complicated. So you should try not to get into that model. And usually you'll not have that type of problem also. Okay. The trace table is super important in the loops because that saves you from complications. You can use your logic and check that your loop is working perfectly fine. So for each entry, you process second, and within that, you process third one when you have 3-dimensional data. But usually we leave it to like 2 dimension here, like this.